Hello, guys. This is episode 14 Trading Signals, another coding session. We're starting now. So, in the previous episode, we got a little bit stuck when we were seeing like very strange behavior. Um, the symptoms of what we were seeing were that maybe because a lot of evaluation of formulas out of place when we were trying to send a signal from a cancel order event at the close stage, debugging that stuff, it got very messy. So the decision was to stop there and to see if we can simplify the formula, the formula's evaluation, and that is what we are going to do now. Okay, so today I'm going to make sure myself I'm going to make myself sure that I have committed my previous changes because I'm going to be touching quite a lot the behavior of the trading bot. Um, so yeah, okay. What I want to do is to optimize the way formulas are being evaluated. Okay, so what is the current mechanism? Let's explore it a little bit. The current way this is implemented, and I don't recall why it is like this, is that these functions are added to the trading system object here. Okay, probably because the trading system object is available at different modules, and this module that is also called trading system is not available at every place that is needed. I'm not sure that is a good idea because it looks a little bit strange for me, in the sense that this technique has not been used in other place or in any other place of the system. Um, I'm not saying it's bad, but it's a little bit strange. Let me continue. So we have the trading system object being manipulated by we are adding these functions that are check conditions, eval conditions, eval formulas, eval user code, add error warning and info. Is it inside? No, this is something else. Okay. Yeah, it looks like this is a little bit messy because on one side, here is coming the execution from the trading simulation into the trading system. So it's holding this execution path with the run, and also from here is running the trading stages stuff. But on the other side, it has functionality related to evaluation. Okay, I will not argue that. So it seems that we have a function eval node that, depending on if the node is a condition, formula, or user code, then it's going to call these specific functions for each one: eval code, formula, and condition. So this is a recursive function that you can give it a node, and then it will go and execute all the other stuff. Okay, then eval condition. This is the function that actually evaluates a condition. Eval formula. This is the function that actually evaluates a formula. And eval code. And this is where it finished. Okay. So I guess the reason we have this eval node is because sometimes we have a branch of nodes. Where is my platform? Sometimes we have a branch of nodes. Like, for example, if we want to evaluate all the situations and conditions of this event, then we send this node to eval node, and it will evaluate everything inside here. Okay. And it doesn't really care if it finds a condition, formula, or whatever. So you have to pay attention with that. So if we send this node, we'll, uh, we'll get all the conditions evaluated. But if we send this code, we'll get all the conditions and also all formulas evaluated. But we don't want to do that. That is exactly what we don't want to do anymore. Okay. So let me check a few stuff. Let's check in here where we have this eval node. Or let's check it here. Well, I'm not easily finding the usage of eval node. Because nobody's using eval node. It's like what we are using is this one: eval condition, eval formula, and eval user code, that because they need a recursive function, they are all reusing eval node. And then again, they are splitting into condition, formulas, and code. What that would mean is that there is not a mixture between conditions, formulas, and code being evaluated, because here we are sending the type of node that we want to actually evaluate to eval node. Okay, the sending of this type of node. Okay, that makes the picture a little bit more clear. So our problem is with formulas, but let me check a little bit where conditions are evaluated. This is portfolio, this is TensorFlow, this is learning. These are trading. So we have one. Okay, the definition of the function of the trading system. And we have many at trading stages and a few at trading orders. So the one at trading orders are to create an order event and cancel order event, okay. And the one at trading stages are trigger on, trigger off, take position, next phase, move to phase, next phase and move to phase. Probably this is for the stop loss, and maybe this is for the take profit, and the close stage event. These are all our events, okay. So now let's check the formulas. We already did the work of reorganizing the places where conditions are evaluated a few episodes before. Now we will do the same with formulas. Okay, so eval formulas. We don't need this here. We don't need this here, and we don't need this here. Learning systems. We don't need that either. It looks pretty similar, to be honest. Um, let's check one by one and see if they are at the right place. Take position event, eval condition, and eval formulas. Why do we need to eval formulas here? Why do we need to eval formulas? My guess is that it's related to announcements and this kind of stuff. So we are at the take position. I want the first one. The first one is the take position. Okay, I'm back. The first is we're here at the take position, take position event, and let's try to guess what is going on. If we had to make an announcement, I can understand that we should evaluate formulas. Otherwise, there are no formulas here. Okay. The normal behavior of the trigger on event is evaluating all these situations and conditions. So, but if I make an announcement, then there is an announcement formula here. But I wonder if that is evaluated, because announcement formula is another type of node, announcement formula, and it's not a formula object. Um, we will have to go into these announcements, make announcements. So where is this defined? Mhm. social bots, announcements. Okay, I'm going to deviate a little bit by checking out this stuff. Announcement. So these already have trading engine, trading system, and trading parameters, and make announcements. It's evaluating its own conditions, and probably it's evaluating its own formulas. Announcement formula eval, announcement formula evaluation stuff, which is fine. Uh, I think this is a good thing. So, what that would mean to me is that this evaluation of formula here is totally in vain. Where was it? Here. It's like it makes absolutely no sense to evaluate the formula here. Um, yeah, so what I'm going to do is to remove it from every place and uh, move the ones that I believed are okay to the places where I believe are okay, and I'm going to run the lightning strike, deleting the information and see if I can get the same result. Um, that is what I'm going to do. So this guy is going to disappear, and let's check again the list. So we got also eval formulas here. Run when started. Hold on. I was analyzing the trigger on, but the code was take position. So maybe there is something here that I'm not seeing. No, there is nothing. Just situations. That's what we have here. Okay, so um, the next one in the list is this one. This we are talking about the open stage, initial targets. Okay, trading position. Okay, who is this guy? Trading position module. Trading engine, trading episode, trading position. What we are saying here is what we're going to say initial targets. Give me 1 minute, please. Okay, I'm back. So we are executing from here this function, initial targets. Um, trying to see what is going on inside. Okay, by a quick look into this, what I see is that what is going on is that we are like standing in here, specifically looking at this node initial targets. Okay, looking at this node. So this node might contain one, two nodes that can be this one or the equivalent in base asset. So in order to proceed, yeah, we need to calculate the formulas of this. And so I don't think it's bad what we have here. We're calculating all the formulas inside there. And that's pretty much what is needed. So yeah, I think we can leave that stuff. So we will return to the previous query, eval formulas. Okay. Okay, we're in eval formulas, right? So what we're going to do is to go to the next guy. This is initial targets, open execution. Hold on, I want to really check this is the right thing. Trading system stage. Why is this given trading system stage and not directly initial targets? Like this is the stage and this is the target. So why do I need to can or crawl the whole structure if I want to evaluate only this stuff? That's my question. So I'm going to do is to modify this, and what happens if the node I send in is undefined at eval formulas? Eval condition, eval formulas. Starting node comes from here into here. And node, if node is undefined, it just return. So my guess is that there is no problem. Trading stage, initial targets. um, I will make sure this exists. Initial targets. Okay, I'm not seeing it anywhere. I'm not seeing this either. Um, so there are two ways to verify. One is using this trick. Look, I get into this node, Control Shift Alt F12, then F12, getting into the browser's console, and I have logged the object that it was on focus, node on focus, and initial targets is the property name. Okay. Um, okay, so I'm going to send this directly the node where I want the crawling of the node branch to start. Okay, so that should improve a little bit what is going on there. The next one. Okay, the next one is here. Runway status is open, and we are here at, again, the open stage. My guess is that this change that I made here is exactly the same, or is needed also at the close stage. Run open stage, run status is opening. So before I forget, I will go to the close stage. And yes, there is another eval formula, and we are going to update it there. Okay. So at the open stage, when the status is open, here it says that we're going to evaluate the formulas of the open execution. And here it's sending the execution node. The execution part of the open stage is what it starts here. Okay, so by evaluating formula there, that means that every algorithm, every order, and every formula of order rate is going to be evaluated all at once. So that is exactly what we don't want to do. So um, I'm going to remove from here this evaluation, and we are going to do it only at the place that we need it. Okay, so at the trading execution, what we have is like we are checking this type of order: market buy, market sell, market limit sell, all through this function check orders that is inside here. So check orders, we will have it here. And here where we are iterating over each order specifically. So somewhere in here we need to find a place where we are going to actually need these formulas to be evaluated, and we are going to do it just before we need it. So if we see it at the order level, what we have actually is only one formula that is related to the order rate. Okay, that's the only thing we need to calculate using a formula. So we should take that into account. The order rate calculate. Okay, and here we have a function to calculate the order rate that is pretty much what we were looking for. Since I have it, I'm going to give it to the function directly the formula node. We even verified before that it existed, so this is the best place I can see to use this. So this is the first formula I'm moving, formula evaluation I'm moving. One thing to take into account is that this is an asynchronic function that is potentially sending signals via the peer-to-peer network, and I'm using an await here. So this must be an async function, and also it must be called with an await from an async function that is also called by an await from a async function that is also called by an await by an async function that is also called by an await at every place it is. Okay, and I can continue going on, but most likely everything is good there. Okay, so what we did was to move the trading system Eval formulas to trading orders. Okay, so where did we put this Eval formula? Okay, my question is this defined here? Trading system? It looks like it is. Yeah. Eval condition, eval condition, eval formula. Okay, this is great. Okay, so we already did the first one at the take position. No, that was not at the take position. At the take position, we remove it. At the open stage, we did the initial targets. At the open execution, no. Okay, the next one we remove it, and the next in the list is this one, run with status is closing. Here we are trying to evaluate the formulas of the open execution. Check if there are unfilled orders. We would check if they were executed. Cancel the. I don't think we will need this one because the only formulas are to calculate the order rate. So there is no order rate needed for checking for cancellation, and even if there is something needed, it's going to go through the function that we already identify. So this is gone. And we are at the open, and most likely there's similar stuff happening at the close. So run will start is closing. Oops, no. Be careful. We don't need this guy. And this is also run when status is open of the close stage. We also removed this one. Good. And we have one surviving here at the manage stage. So we have an eval formulas for the whole manage stage. That doesn't look good at all. Let's check out what the manage stage means or is doing. So we close all this and we are going to be watching inside here. So we have only one formula as far as I know, because these are events and these are signals. And the formula is the phase formula, which essentially is going to calculate either the stop loss or the take profit at each phase. These are the formulas, but we don't need to calculate all the phases. Or do we do? If you are not in a certain phase, why we need to calculate all the others? That's my question. Probably the answer is we don't need them. So we are going to move it. So I will try to find where is the place where to put that. Okay. So it looks like that the calculation is done also here. Calculate stop loss just here. Um, so when it calculates the stop loss, it gets the strategy, the current strategy. It gets the current phase. And if the formula is undefined, it makes this trading position module apply stop loss formula. Okay, this is a good candidate of a place where to calculate the formula, because I'm going to send this phase formula and I'm going to send this formula, because we already filter out uh, the one formula that we are currently needing because of this line. Okay, and exactly the same stuff we could use here at the take. We use phase formula here, and that would be good enough. Then this apply formula at the take position object. I don't know exactly what it does, but we don't really care that much. Um, where is that take position object? Yeah, it doesn't really matter, because now we already filter and we are standing at at the phase that we are all actually running at this candle. So this is the right place in my view. So I'm going to put a breakpoint because we finished the list. so far. Let, let me check this. Something is not looking good. Why we have these eval formulas? This is the close stage, initial targets, and if I recall, the evaluation was being done here at the open stage, not at run when it's opening. This is run when it's opening. Um, Run at the open stage. Okay, run when it's opening, yes. And we are running this. Then we don't have. Okay, yeah, it is run when it's opening. But the difference is that we are sending the specific node initial targets there. Okay, so this is the same that this one, and these two are the same also. We are sending directly the phase formula, and this is for calculating the stop loss and the take profit when we are standing at a certain phase. Then the other formulas we need are when we are, well, this is the eval formula definition. This is the eval formulas. Dynamic indicators. I don't know what is that doing here. But we have also the eval formulas here, but I don't know why they don't appear in the list. Maybe I delete them. Trading orders. Yes, there's this one. The order rate formula, okay? So we're going to put a breakpoint there. And okay, so I think we have covered all these situations. Um, Probably I'm not going to debug line by line because I'm confident this is going to work. So what we are going to do is to go and run it. We will come here and delete the data of the trading bot, data storage, projects, algorithmic trading. We're going to delete this and we are going to run I think if I run this one or I run, because this is it's going to be trying to send signals and it's slow. Um, I will make myself sure that this runs. So I'm going to use the workspace getting started. That it has the original lightning strike strategy without any changes at all. Okay? Okay, so let's recap a little bit. What we are doing here is reorganizing the places where formulas are evaluated, because when this code was done, it didn't have any impact to evaluate all the formulas of the whole branch of nodes at the same time. Even if we even if that happened more than once, because evaluation was just about that. Now evaluating a formula has a different impact, because if the body is receiving signal, it has to fetch the signal, and if it's sending signal, it has to send signal, and that implies asynchronic operations, eventually calling other programs somewhere else. So this reorganization makes a lot of sense. Okay, so here is the getting starting workspace, and I'm going to just run this strategy with a modified code. These are our modifications. At trading stages, we remove several of these calls and or change it to other places. And at trading orders, we put one. So it doesn't look like a very big deal. Let's see if it works. Mm-mm. It doesn't look that it's going to work. Await is only valid in a sync function. There is one await inside, and it is at trading stages 511. Well, I reviewed some of those, but it seems that there was one that I didn't. 511. Okay, calculate stop loss. And also in this one, calculate take profit. Okay, you're right. This should be an async function. This should be an async function. And the caller of this one should have an await and be an async function. Okay. Okay, let's try it again. When this cancels, it doesn't restore itself. Bad. That's a bad thing. Okay. So we'll wait for a minute for this to load again and try it again. Okay, the running looks good in the sense that at least it ran. Well, let's check the charts. The charts pretty much can tell you if things worked or not. We will look for the 1st of September 2020. Zoom in. Hmm. Episode. Okay. Well, unfortunately, it, it didn't work. There should be a bunch of order placed, but I don't see any of that. So we will have to debug this and see what failed. But another thing we can do here is to see if there were errors during execution, which they were. That means that probably at the console, no, there were no crashes but errors. So we don't need this highlight system status, we just want errors and warnings. Okay, there is one error everywhere. Rate value undefined. Okay, you must properly define a rate for the order by using a valid formula under the rate node. Rate value undefined. So what we're going to do is to search for this in the code. And I guess it's over here. Rate value undefined. Oh, look. I can see the problem. This is a filter for the Eval formulas that is only to going through this type of node. So probably this was the problem. Okay, but I haven't shown this trick before. If you are watching this video learning, there is a pro tip. Errors are plotted at the chart and you can see what's going on just by turning on the trading system error layer, this one, and that's pretty cool. Also, the stuff with error are going to be highlighted, which is also pretty cool. So with that fix it, let's run this again. Okay, so this already ran. We can stop it and check it out. Now it looks beautiful to me. So this is exactly how it looks like when it runs well. So the whole stuff is working again, but with the formulas being executed just when needed. So immediately, because we already tested, we're going to commit this. So formulas reorganized. And the next thing to do is we are going to go back to our workspace of trading signals and see, run another test to see if this fixed the problem that we were having with the bot not being synchronized with the one emitting the signals. Um, that's what we're going to do. Yeah. So for this test, we will need our network node to be running, which is already running. Um, and we are just going to run both nodes at Node.js and look at the charts. Okay, so we are going to delete all this trading data, even though that's not really necessary, but I want to be sure that what I'm seeing is 100% the latest execution. So the way to run this test is running both tasks and waiting for them to be ready. And once they're both ready, we will run first the bot emitting the signals, letting run for a while. And after a while, we will run the bot sending the signal. Also, as you can see now, there's a difference on speed. This is going faster because less signals are being sent, less messages are being cryptographically signed. So there is an improvement that is noticeable here. Performance. Okay, so Remember, there is still something we need to fix, and it is that we should be able to run both bots at the same time without needing to wait for the first one to emit all the signals. That is something that is pending, and if we manage to solve all the previous problems that we already have, the next one is that. Okay, so this is almost finishing. Going to run this one. All right, so we're going to stop these tasks and check out the charts. Okay, the bot sending the signal looks good. It's doing its job. The bot receiving the signal doesn't look good. It even looks worse than before. It looks worse because before we got the execution up to here, and even with to the other stage, now it didn't it didn't place the orders. What could have gone wrong? Ooh, we have errors here. Two errors. First one, evaluating formula error. While running at the task server, this bot encountered an error. Cannot read property undefined. Okay, where did this happen? Okay. So output management, run simulation, run cycle, run open stage, run when status is open, run execution, calculate order rate, eval formulas. Okay, the problem is with the order rate. At trading orders, calculate order rate. Trading order 394. Exactly where we were. So for some reason, this guy, when it comes in here, and it tries to evaluate the formula, it gets the signals like undefined, and then the code inside doesn't check if this is undefined and it crashes. Okay, so we will need to debug this to know what is going on. So we will remove all the debug. Okay, not this one. Breakpoints. And we will wow, that looks like a mess. Okay, so how are we going to debug this? We will run this guy again, and we will run this on debug mode. When it is running, I will start this task in debug mode, and then I can send the signals when this is running. I will send the signals, and I don't really need to wait for this because the problem happens right away. So I will run this and wait it to stop here. Oh, there's another breakpoint here. Okay, so here we are. Okay, this is our call stack, calculate the rate, try to open order, check order, blah, blah, blah. So now we'll get into here. Oops, what happened? F11, send me somewhere else. Okay. Eval node. This goes well. Is it a formula? Yes, it is a formula. Eval the formula. This goes well. So get all signals, it returns undefined. The parent node is undefined, so there is a problem here. Because when we are evaluating formulas, we need to send which is the parent node. In order for this function to know this needs to know the parent node in order to find the signal reference and all that stuff. Okay, I understand that. So eval formula. Probably this was the problem yesterday. What I'm not seeing is a single place where I'm evaluating formulas that I'm sending this right. So how was it working yesterday? Maybe the places where I delete them eval formulas. I'm not seeing that even yesterday we were sending this. So I'm wondering how this was working before. But well, anyway. What I'm seeing now is that this guy needs the parent node, and eval condition, no. But eval node has the parent node, and I'm a little bit confused now. Okay, the signals are sent because the conditions need the signals. And the parent node is sent because the formulas need the parent node to get the signals. Okay, so I really don't understand how they was working before, at least partially. Because here there is not even a parameter for wait, hold on a second. Starting node formulas. Oh, here. Starting node and descendant of node type. Okay. And descendant of node type. This has the signal parameter. Where is the parent node? Ah, the parent node is not sent. Is automatically discovered when you send a node that is higher at the hierarchy of nodes. So when this goes through here, then it discovers the parent node. That means that you cannot send directly the node to be used because then it will not know which is the parent node, which is a little bit tricky. So, what is the solution to this? The solution might be, okay, I can send a node higher and force it to go this strange path, or I can add a parameter here, eval formulas, like in eval conditions, I'm sending signals. Here I should send the parent node. Mm, parent node. So if the parent nodes come here, then the eval node one, two, three, four verify this node is descendant of the specified. Okay, so one, two, three, four. The fifth parameter is the parent node. So one, two, three, undefined, and parent node. Okay. So in the case of the trading order that I'm sending directly the formula, I could send the order rate node and it would work. But also I can send the order rate as a third parameter, that is the parent node, and this should work. Okay? So let's try this out. Let's try this out. There was a second error here, but most likely it's related to the first one. Okay, so let's go again. We will run this guy, and we will run this guy, both at Node.js only, because we will see any error there as we did before. So you can run now. It's a little bit slow. We will let it run. Okay, I believe we are at the last stages of this to work. It was a good reorganization of where formulas are calculated and how. Now we have a pretty good understanding of how this is organized. And, and yeah, I hope that once every single signal type gets synchronized, we will have a perfect synchronization of the two bots running exactly the same strategy at every single point. Um, a pending task is to solve the problem that when the bot receiving the signals is going faster, that the session stops instead of waiting for the other. Okay. If this works now, I will fix that at the next episode. So let's run this guy. Or why is this still? Okay, hopefully this is going to work. Let it go. Wow, it's stopping at. No, it's not stopping. Okay, both tasks ran completely. Oops, I don't see. It doesn't look good. In fact, it looks bad. But there are no errors now. Why is not showing anything? Trigger stages. I don't see the open stage. Something's not good. Let's check the console. Mm, oh my god, I don't know what's going on. I don't know what's going on. Episode, it shows me this. Strategies. So show me the strategy. Trigger stage, it doesn't show me the trigger stage, which is very strange because we touched nothing about that. open stage, manage stage, close stage. Um, I'm a little bit suspicious about the data now. Probably what I'm going to do is to delete this data. Okay, I cannot see anything now. um, I don't know. Let's give it another try. So both stuff are running and connected to the network node. We'll run this one first. I'm not going to let it run all the way, just the first 100 candles are enough to know if this works or not. So you can run now. But somehow it's waiting for the other. I wonder if that waiting is disrupting the process of recording the information that was produced. Yeah, it's saving every time. Yeah, so the problem I thought I had of not waiting and just stopping the session is not really happening anymore. So this what is going on is that this simulation is running until it gets to catch up with the one producing the signals, and then stops, saves, and run again, wake up, and run again, and catch up. um, which is super cool because that is exactly what we need. The only thing that is wrong is that I didn't see the charts. Okay, both guys finished. In this case, it made an internal loop all this time that it was saving and waking up again. Let's see the charts. Do we have episode? Yes. Do we have strategy? Yes. Do we have trigger stage? No. Do we have limit buy orders? Limit sell orders? No. So, my guess is that something is interfering. Do we have errors? No. Um, Something is interfering in the process of saving the outputs or something like that. Um, Maybe one thing we can check is here. Backtesting, receiving signals. For example, um, trigger stage objects. Okay, so yeah, uh, something is broken. The file is being saved because the hour is right, but something is broken. I would like to make another test, that is, let this run ahead and finish, and we will run the receiving bot only when the other already finished. I cannot really imagine what could be wrong when what we are doing is that we are breaking the loop when we find this situation, and when it catch ups we break the loop, but when we break the loop probably we are not executing some code that is being executed before breaking the loop or something like this. So that may affect the saving of the stuff. So my guess is that if we don't let this bot to catch up with the other, we're never going to break the simulation loop, and therefore the problem is not going to happen. But we will see. This session is getting a little bit long, but we really need to finish this. Okay, just a little bit more. 1440 candles per day we have. Almost there. So here we go. It's pretty fast. Okay, all this ran without any of these internal loops. Okay. Okay, do we have episode? Yes. Do we have strategies? Yes. Do we have trigger stage? Yes. Do we have limit by orders? Yes. Limit sell orders? No. Um, open stage? Yes. Manage stage? Yes. Okay. Okay. So we have this kind of working again. Um, there's still something. Obviously, there's still something. Um, I can see errors here. Let's check them out. Maybe there is something easy to fix. Error evaluating formula. Which formula are we talking about? Okay, the thing that it doesn't close the stuff might be related to the stop loss and take profit formula. The stop loss are related to the phase formula. And the phase, let's search for where we were defining the phase formula. Okay, it's happening the same stuff. We are sending directly the formula node and not the parent. Okay, so we are having the same problem. Okay, so we are sending the formula but not the phase. And here at the stop loss and also at the take position. Okay, I know this is a long episode, but we are almost there. Hold on. I believe we are going to make it now. And by the way, let's check this. Initial targets, we are not sending the formula, but we are sending the formula here. Okay, so now we should be good now. So again, let's run this guy. Again, let's run this guy. And once they are running, we will run the first guy. Okay, while this is running, that takes a while, we are going to check the code of the simulation and what can be going on when we break the loop, right? Why is it that it's messing up the recording of? So here the loop starts, and here is where we are getting out of the loop if we are supposed to get a signal and we don't get it. Okay, here it is. Another technique would be to just wait for the signal in a kind of loop that stay here forever, and we get the signals and until we don't get the signal, we just get stuck there. The problem is that there's no natural way for this to stop unless the signal arrives. Otherwise, the process will be staying there forever. So here I see how this executes. Append records. Check if we need to stop. Run cycle. Check if we need to stop. Let's collapse this and collapse this. So here is where the loops end. There's a check here. Check if we need to stop after both cycles. So is a way to break the loop in a way that is not harmful. Yeah, because it does an append records. And then it breaks the loop. But this append records is done at every loop cycle. So that doesn't explain really why. Okay. Um, so what's going on with this task? Almost finishing. Yeah, I'm not 100% sure we need to stop the loop, to break the loop and let it go and save, because we are actually waiting for the signal. So we don't really need all that execution to unload everything, to load it again. We just need to wait for the signal. So if a signal did not arrive, I don't know. We have to think this over. Okay, let's run this guy. This ran until 2:14 and then it stopped. Not really good, but this is what we have. Okay, so we are at the same place we were the other day, where the cancel event didn't work for this. And we have a maximum balance reach. What is this? Okay, so we are a little bit better than before. Now we are entering into the close stage, placing this order, but the order is not being cancelled. It should be cancelled every two candles and go through other order orders that are predefined there. Um, so we will have to leave this for the next episode. Um, at that episode, we will try to figure out what is going on. We are exactly at the same point of two episodes before, to be honest, that this order was not canceling and the execution was very strange when debugging. So we will get we will get a fresh episode to try to tackle that problem and to see if we can move forward until the whole execution is done well. Okay, so this is all for now. I hope you like this one. There was a little bit of coming and going, but this is how this works. Okay, thank you for watching and hope to see you next time.